Have you ever wondered what it would look like for a country to build the foundation for the next 100 years of technology all at once? Well, that's exactly the idea behind India's quantum leap, a massive, ambitious dive into the strange and incredibly powerful world of quantum tech. So let's break down what this mission is all about.
Just look at that number, 6,000 crore rupees. To put that in perspective, that's over 700 million US dollars. And that is the price tag for India's national quantum mission, an ambitious 8-year plan to not just, keep up with the next tech revolution, but to actually lead it.
Okay, so that brings us to the big question, right? What even is quantum technology? And why on earth is it worth $1 billion bet? To really understand the investment, we've got to first understand the mind-bending science behind it all.
So, let's get into the specifics of India's quantum bet. This isn't just about throwing money at a few labs. Oh no, this is a really carefully designed blueprint with a crystal clear set of strategic goals for the future.
And these objectives are incredibly ambitious. I mean, it all starts with seeding cutting-edge research, sure, but it does not stop there. The real goal is to build an entire industrial ecosystem around quantum tech, use it to drive economic growth, and ultimately put India on the map as a global leader. It's a total, top-to-bottom strategy for building a new technological future.
To really get the scale of this mission, we need to understand the toolkit they're working with. And that means we're going to take a quick peek into the bizarre, yet unbelievably powerful rules of quantum mechanics that make all of this possible. You see, everything you're using to watch this right now, your phone, your computer, it all runs on what we call classical bits. Just think of them as tiny light switches. They can either be on or off, a 1 or a 0. Simple. But a quantum bit or a qubit is a whole different ballgame. It's less like a switch and more like a dimmer dial with infinite positions. Thanks to a wild principle called superposition, it can be a 1, a 0, or somehow both at the exact same time. This strange ability is called superposition. Here's a way to think about it. Imagine a spinning coin. While it's in the air, spinning, it's not really heads and it's not really tails. It's kind of a blend of both possibilities at once. A qubit holds that same kind of uncertainty, and that, right there, is its superpower. It lets a quantum computer explore millions of possible solutions to a problem all at the same time.
Now, if you think superposition sounds a little weird, get ready for the next concept. This is the one that even had Albert Einstein scratching his head. He famously and kind of skeptically called it spooky action at a distance. He was talking about entanglement.
Entanglement is when you link two qubits together, so their fates become completely intertwined. Imagine you have two of those magic coins from before. The moment one of them lands on heads, you instantly know the other one is tails, even if it's on the other side of the galaxy. This spooky connection is the absolute key to creating things like ultra-secure communication. Why? Because if a spy tries to peek at one of the particles, the other one is instantly affected, blowing their cover.
So how is India actually planning to use these mind-bending new tools? Well, the National Quantum Mission is built on 4 key pillars. They're calling them thematic hubs, and each one is designed to pioneer a totally different aspect of this new technology.
So, these pillars are quantum computing, quantum communication, quantum sensing, and quantum materials. Each one of these represents a technological frontier with absolutely game-changing potential. Let's quickly run through what each one aims to do.
First up, quantum computing. The goal here is to build machines that can solve problems so complex they're way beyond the reach of any supercomputer on Earth today. This could mean things like designing life-saving new drugs by simulating molecules perfectly, or creating hyper-efficient AI by untangling incredibly complex systems. We're talking about a monumental leap in computing power.
Next, we have quantum communication. Remember that spooky entanglement we just talked about? Well, this is where it's used to create perfectly secure networks. The idea is that any attempt to eavesdrop on a quantum signal fundamentally changes it, which instantly reveals the intruder. This could mean truly unhackable systems for finance, for defense, for all of our critical infrastructure.
Then there's quantum sensing. This is all about creating sensors so unbelievably precise they can detect the tiniest disturbances imaginable. Think about medical scanners that can map individual processes in your brain in real time, or navigation systems that work deep underwater where GPS signals can't even dream of reaching.
And finally, quantum materials. The goal here is to basically design and build brand new materials from the ground up, atom by atom, giving them specific quantum properties. We're talking about things like next-generation superconductors that could work at room temperature or radically more efficient batteries than electronics.
Now, it's really important to remember that India isn't developing this technology in a vacuum. Mastering quantum is pretty much the next great technological space race, and believe me, the competition is fierce.
And hey, this isn't just some plan for the distant future. The mission is already hitting key milestones. A fantastic example is the goal for 2025 to develop India's first quantum diamond microscope. I mean, that's a device sensitive enough to image magnetic fields at the molecular level, a massive step forward for materials science. It just goes to show this mission is moving from theory to tangible, real-world tech.
And the reason for this urgency becomes crystal clear when you look at the global landscape. Countries like the United States and the nations of the European Union are also pouring billions and billions of dollars into their own quantum programs. So for India, developing self-reliance in this field isn't just an economic goal, it is a strategic necessity.
So after all this talk of qubits and entanglement and global races, let's bring it all home. Why does this mission truly matter? For India, and really for all of us.
At its heart, it really comes down to this one quote from the mission's own objectives. It's about building an entire ecosystem, from the scientists in the labs to the startups and industries, that will drive the next wave of economic growth and innovation.
The impact of this tech is going to ripple through just about every part of society. Just think about it. Healthcare, totally revolutionized by custom-designed medicines. Finance, transformed by truly secure digital economies. National security, bolstered by unbreakable codes. This isn't just about one industry. This is about elevating our entire technological landscape.
So the ultimate takeaway here is this. India's quantum mission isn't just about building faster computers. It's about being an architect for the next era of human innovation. The quantum future, it isn't science fiction anymore. It is being built right now, today. And the real question is, are we ready for the world it's going to create?